Hello, students. I got an email asking about question number 3, and this is out of 2.3b. I guess I should try to write that up here. So 2.3b, annotate. So 2.3b, question number 3. So the question says, tell whether each of the following is true for all sets. Okay, we have a quantifier. All sets means it has to be true for every single one of them. If false, give a counter example. So as you're looking, you want to try to get an idea for whether this is true or false, because maybe a counterexample would be pretty quick. Okay, so let's take a look over here. So here, first one, I have A set difference B. Okay, we know what that represents. If not, we can go back in the book, check the video. We know that this is everything that's in A, and then we kind of pull everything out of A that's also in B. So we take those out of the set, and we have something that's left over. And the question is right here, or the statement says that it is equal to A set difference, the empty set. So as you're looking at that, remember the empty set has nothing in it. Has nothing in it. So to you, hopefully you could say, well, I know that A set difference, the empty set is A. So the question really is now, is A set difference B equal to A? Now you might be thinking, okay, that might be true sometimes. Just remember, we're not looking for sometimes. We're looking, is this true for all sets? So if I were you, I might try to create a set. A equals, let's take the set of, I don't know, A, B, C, D, E, something like that. There's A, okay? Okay, so now can you come up with a set B that if you remove the elements in B from A, you do not get A itself? That would be a counterexample. So let's just try a CHK, something like that, okay? So now we know this right here, this is A. This is also the same thing as A set difference with 0, or the empty set, I should say, not with 0, set difference 0. So there's that. Now come down and we got to create, we got to say, okay, what is A set difference with B? Okay, well, I need everything that's in A, and you got to take out the stuff in A that's also in B. So that means it would be A with B with D with E. Okay. So the question is that it's asking, is the thing over here equal to the thing over there? Are those two sets exactly the same? And you can say, no, they are not exactly the same. All right, since they're not exactly the same, you have yourself a counter example. So that counter example kind of gives you an idea of what we're looking at. Now, you can also do this. You saw me in a couple of videos do an example with with pictures, okay, just to kind of see if it's true or not. And so if you think of A, so if we label this one over here as A, and we label this one over here as B, right? So then A set difference B is going to be all of this stuff. I kind of shade that chunk right there. There we go. That's about as good as it's going to get with that drawing. Oh, there's A set difference B. Okay. And now, is that equivalent to A set difference the empty set? Well, A set difference the empty set would be everything that's in A. So it'd be kind of this whole thing. And you'd have to ask yourself, are those, that missed by a little bit. Let's see if we can get up there. There we go. Are those two exactly the same? And I would say they are not the same. Then I could go create my counterexample. So that way, when I have a new one like this, part B, I could say, okay, what's not in A union B? So if I was doing A union B, then that would represent everything that's in A or B. So that's everything in here, everything over here, and all of this stuff. So I'm kind of shading all of it. I'm doing a pretty quick shading job, or at least I'm trying to. Okay, that's A union B, but I want the complement of that. So if you take a look, the complement would be everything that is outside of those circles then. Okay, so that's all the stuff that's out here. right? There's everything there. So that right there in your mind, you can kind of even have a little sketch of it on the side and say, okay, the stuff I want is the stuff that's in blue. So this right here, all of this is the blue one. I can even come down and erase the inside piece. Okay, so that's the complement of A union B. Now our goal is to see if that's the same as A complement union B complement. Okay, so in order to do that, maybe I need a different picture here so we can kind of make sure we have the same thing. And let's get some circles in here. So there's A, here's B. Doesn't matter that they're not perfectly circles. And so I need A complement union B complement. So A complement is anything that's not in A. So all the stuff around the outside, just don't get anything in A. So I'm gonna try to shade. I'm using my mouse right now, so it kind of, obviously I cannot color inside the lines. I would not win a coloring contest in your future classroom. All right, there is what's not in A. Next one is what's not in B. What's not in B, maybe I'll use green. What's not in B would be everything out here, outside the circle, and everything over here. It just can't not be in B. Okay. And so the question then says, so that's not in B. And notice the symbol between them is a union. So that's an or statement. So if you have that, does that mean that these are the same? An or statement would be on the right-hand side, anything shaded with any color. And on the left-hand side, anything shaded in blue. Are those looking exactly the same? And hopefully you would say no. This side has this portion shaded, also has that portion shaded. That is two things that don't match. And that would give you kind of an example of, okay, let me create sets A and B where set A has to have some things that are not in B. Set B has to have some things that are not in A, and that should take care of it. And then give yourself a universal set too. So if you're doing this, maybe it's okay to say, okay, my universe is the set 1, 2, 3, 4, 5, 6, 7, something like that. There's my universe. And then just come down and say, well, I need a few of these, right? 1, 2, 4. Okay. And B, they can overlap, but I need some things in B that are not in A. So maybe this is a 1, 3, 5 or something like that. Okay. So then if I take what's not in A complement, that would be 3, 5, 6, 7. What's not in B complement would be 2, 4, 6, 7. And I put the union of those together, and I've got 2, 3, 4, 5, 6, 7. Okay. So it's basically everything but 1. Now, if I take the union of these two, right, which would be a 1, 2, 3, 4, 5, the union of those is 1, 2, 3, 4, 5. The complement of that would just be 6 and 7. So those are clearly not exactly the same. So that would be your counterexample for part B. Okay. So that's kind of the thought process. I don't think I want to go through each one of these, but you can kind of take a look. You can draw the picture if you believe, hey, the picture is going to help me first to see if it kind of feels like it's right. And then you can kind of use that picture to say, okay, what kind of a set do I need to create? For some of them, if they're clearly not equal, or if you're not sure, you could just create some sets. Again, try to give yourself that flexibility. Don't put everything that's in B in A and vice versa, because that'll actually create a problem later. You may not know why it's true or not true. So that gives you a pretty good push on question number 3 for section 2.3. All right, off you go.